India's science and technology on a higher scales, especially at a competitive level of the Western side, and recently I would say that Eastern science that China is not doing. So, guys, before I invite Professor Rao, I would like to introduce briefly about him. You must know that he does not need any introduction because he is an established researchers, leaders, and innovators in India. But then I would like to briefly explain that Professor V. Ramgopal Rao is a Vice-Chancellor of Birla Institute of Technology presently, and before joining the BITS Pilani Group as a Vice-Chancellor, he served as Director of IIT Delhi for the last 6 years, and a Chair Professor of Nanoelectronics at IIT Delhi and IIT Bombay same time. Professor Rao is an nanoelectronic researcher. He has 500 research papers and 50 patents, which include 20 US patents. Interestingly, 15 of his research patents has been licensed for industry and commercializations, and the IP and CMOS SOC applications developed in his group, and now is hundreds of millions of ICs sold all over the world. Professor Rao is also a co-founder of 2 deep technology startups in IIT Bombay, NanoSniff and Soil Sense, which has successfully commercialized product in the market. For his research accomplishment, he is already awarded for IEEE Fellow of the World's Academy of Science, Indian Academy of Science, Indian Science Academy of Science IASc, and National Academy of Science, and Indian National Science Academy. Remarkably, he has supervised 52 PhD students, which is huge, I would say, and these students, I'm sure, would have been leading a multiple aspects of research and technology, both in academics and in industry. Other than that, Professor Rao's research and leadership contribution has been recognized by the numerous awards, which would be, I would say that some of them I can count, that would be the Shanti Swarup Bhatnagar Prize, which is most prestigious for the young industry in India, Infosys Prize, IEEE EDS Education Award, and many more. He is also serving as in many editorial advisory boards of many journals or many patent office or something like that. And he must have reviewed for hundreds and thousands of, I would say, the papers, which would be IEEE journals and flexible electronics, etc. So with that, sir, on the behalf of AIRSA family, I would like to welcome you and deliver the talk, which will be helpful for the young investigators to understand where India is going to and what would be the policy that will help India to lift up and be competitive in the science and technology across the world.
Thank you. Thank you very much.
Professor Rao.
So is it okay now? Can I start now? Shall I share?
Yes, please, sir.
Yeah, okay. Let me see. I hope you're able to see my presentation. Are you able to see my presentation? So,
yeah.
Yes, sir.
Yes, sir.
Yes, sir. Okay. Okay. Yeah. So I will take about 40 minutes. Then we can have discussion for maybe 15-20 minutes. So I'll keep it short and more multidisciplinary. And I have been talking about these issues at multiple fora. Just yesterday, I gave a talk to IIT Bombay Alumni Association, on some of these aspects. But I will give you an overview of what I believe are the challenges in India and what India needs to do so that we can ignite that innovation. And so India is a large country when it comes to the higher education system. We have, though we have a low gross enrollment ratio, which is just 27%, but we still have about 43 million students studying in universities, and with a 50-50 kind of a gender ratio, which is again good. And this is slightly dated. The PhD, there are about 300,000 PhD students, doing around approximately 300,000 PhD students who are doing PhD in our educational institutions in India. And so therefore it's a large system. And most of this research is done by the PhD students. And even all the work that I am presenting here is all the work done by PhD students. So that way, I think all credits go to the PhDs. I mean, I always say that a faculty member is as good as his or her PhD students. Even if you have great ideas, if you are not able to attract, quality PhD students, there is nothing much you can really do. You need to mute the other people. I think there is some noise coming in from somewhere. And if you look at the Indian R&D, India, as I said, large number of institutions, over 1,000. First in the number of institutions. And in terms of the number of students, we are not the largest. China has more students. Second in the number of enrolled students in higher educational institutions. And in research, we are ranked third right now in the world. And we are also filing enough patents now, which is something that has changed. Though, we can talk about the quality of these patents and what is happening after the patents are filed. But in terms of numbers, we are definitely doing very well in terms of patents too. And then the ninth for citations, right? And so which is again shows that there is quite a bit of good quality research also happening. But I think the challenge lies after that. I think we are doing a lot of research is clear. Whether it is good, bad, all of that is debatable, right? But what is happening out of this research? What are the outcomes of all the knowledge that we are generating? That is one thing where I believe there are challenges. 39th for innovation. Innovation, I define it as making value out of research. Right? You have published 100 papers, but what next? I mean, if those 100 papers did not yield anything in terms of an outcome, right? If people have not cited the work enough, and if nothing has happened in terms of improving some aspect of some product or process or something out of that research, then one would question the quality of that research. Therefore, innovation here I am defining it as the value generation out of the research. So from that point of view, we are ranked 39th for innovation. A country which is ranked third for research, 39th for innovation, I think it should worry us. Why is it that we are generating so much of knowledge, but nothing seems to be coming out of that knowledge? And 54th for percentage of GDP allocation for R&D. We are not spending enough money, unfortunately, in India for scientific R&D, which is a matter of concern. And one of the reasons why we are doing so poorly on innovation is because of our poor academia industry collaboration. There's hardly any industry collaborating at a level that we can talk about. Some transactional kind of relationships exist between academia and industry, but a deep engagement with between academia and industry, you don't have too many such examples right now in the country. And so for academia industry, we are ranked 66th in the world right now out of some 130 countries rated for this. So which is a matter of concern. We also don't have enough researchers, 81st in the world for number of researchers per million population. So whereas we have about 300 scientists per million population, whereas US, for example, will have about 4,500 kind of scientists per million population. So there lies all the difference, right? We have, in any area you take, there are so few people doing quality research. We are not spending enough money, and our academia and industry collaborations are on a pretty weak kind of a wicket. And these are the challenges. So I think if you ask me what is that we need to improve in this country, we need to do much more, either by government or academic institutions or industry, in bringing academia and industry closer. That's one thing which is required. We need to scale up our institutions. We need to hire more faculty in our institutions. Some of the finest institutions in this country, right, have 30 faculty or 40 faculty. Look at JNCSR, Jawaharlal Nehru Center for Advanced Research. Per faculty output in JNC is the highest right now. I happen to be chair of the board of governors of JNCSR, one of the finest institutions in the country when it comes to research. And almost every second or third faculty member is either a Bhatnagar awardee or a fellow of an academy, right? With that kind of a high quality institute, there are just about 45 faculty. That's all. I mean, institutions like JNC must have 200 people, right? I think the reason is we are not expanding on our quality educational institutions. And that is one major concern. If we ever want to increase the number of researchers, we need to hire more faculty, create more positions in good institutions such as JNCSR. The same is true of any of the DST institutions that you take. There are so many great institutions run by DST, Department of Science and Technology, but all of them are tiny, 40 faculty, 50 faculty. Each institute of DST is like a department in an IIT. That is what it is right now. And I think we need to scale up our researcher base. We are not doing very well in terms of number of researchers per million population. We need to invest money for making all of this happen. And the research connected with innovation is what generates jobs, right? If you publish a paper, the paper is not going to generate any jobs, right? If that research that you published is used by an industry to improve their process or to develop a new product, right? If that kind of thing happens, then the product development, the process improvements, they generate new jobs, they open up new avenues for that industry. Therefore, they will require more people to work in that industry. So that is the reason why research and innovation always need to go hand in hand. The knowledge that you generate must become useful for industry at some point so that they can make use of that and eventually create more jobs for people. And I think in India, unfortunately, that research to innovation bridge is broken. And research is happening in its own silo. Innovation, whatever is happening, but not based on the knowledge that is getting generated out of these academic institutions. And India, though we are ranked third in the world, but we are way behind China and US, which have gone quite ahead. And even the Indian industry is not
Hello, sir. Sorry for interrupt you, sir. We are not audible. So there's some issue from I think your end because there you are not audible.
So voice is not audible. Sorry, please.
Sorry for inconvenience. Please wait, and sir, maybe sir will join again. Is there some voice issue?
Okay, sir.
I think talk is going very well and very insightful discussion, and really, I'm, I will learn so many things in this talk. But somehow there's some interruption, so some technical issue. Please wait, and sir will join again.
Can you hear me now? I will share again. So, yeah.
Sir, yes, sir, yes, sir.
And when did I lose you? I mean, when did you stop listening to my voice? So, from the beginning or not from the beginning?
No, sir.
No. Only the one means the within for
3 minutes
few
back.
seconds.
Okay.
Yeah,
3 minutes back.
Right. Okay.
Almost three.
Okay, thank you, sir.
So this is what we were discussing, right? So yeah, this is where it now you are able to see me, right? You hear me, right?
Yeah.
Yeah. Okay.
Yes.
Yes.
Yes,
I'll
sir.
start from here. Then when there is a if there is a problem, please do let me know. And so I think this is the challenge. I think we need to make our higher educational institutions connect with society, connect with industries. I think we need to link innovation with knowledge generation. I think this is what the R&D that is happening eventually, needs to be used by somebody in India to develop new jobs and all of that. So that's what must happen. Otherwise, India is doing very well in research. You take any of these high technology areas, India is among the top 5 countries or 6 countries kind of a thing. And so that way, I mean, United US and China are of course way ahead. But if you look at other countries, we have definitely been doing very well. But the amount of money both US and China are spending is mind-boggling. The kind of funds they spend on research and higher education and all of that. But India, given its resource constraints, is still doing pretty decently. Since I talked about innovation, the innovation is also linked to new age industries, right? The creation of new companies. And if you look at India, India is a startup nation, right? India is ranked third in the world when it comes to startups. There are something like 117, 118 startups right now, right? But the most of these startups, if you look at, they are not deep technology products, right? They are not. We have not been able to create any unicorns out of products, the deep tech research, and there are some now which are beginning to happen. I'm aware of some of them which are there's at least one molecular biology company, Molbio, in Bangalore. It's now isn't unicorn kind of a thing, but there are not too many success stories when it comes to technology and research based product development, and then those companies becoming unicorns. But most of the unicorns that you see today are what I call the business model innovations, meaning these are all basically aggregation models, right? Somebody is aggregating shops, somebody is aggregating taxis, somebody is aggregating trucks. Those kind of models are aplenty. And there are also a lot of e-commerce companies, a lot of fintech companies. So I think those sort of startups we are able to do very well, and that ecosystem for building the such kind of startups exists very well in the country too. But when it comes to taking your research and then starting a company and then making it big, I think that ecosystem still has to develop in the country, and that hasn't unfortunately happened so far. And but who will do that? Who will translate that research into innovation, right? In academic institutions, there are three aspects that we talk about. One is education, the second is research, the third is innovation. Meaning you generate research, but you also make use of that innovation to develop new products and technologies. And ideally, the research to innovation translation must be done by the industry. And that is where academia industry collaborations become very important. But in the absence of industry coming forward and working with academia, how do you do that? You just can't be waiting for industry to come collaborate with you, take your technology, which is a very long drawn process in India. As a result, academic institutions also need to start building startups, start building expertise, and academic institutions also have to take this role of building or initiating entrepreneurship and startup activities among its research kind of folks. And that's where the PhD students, can PhD students become entrepreneurs? Right now, not even 5% of PhDs even think of entrepreneurship. Today, most of the entrepreneurship that you see is all happening out of the BTech and graduates. But can we now orient our PhD students to become entrepreneurs? That is one thing which I have been trying, and I will tell you a little bit of that. And I will skip some of this. But what are the things now? If we want to do that, what are the things that we need to do? First of all, India needs to spend more money. Right? Without spending money, you cannot develop new technologies. You can only develop some poor man's way of doing things, but that cannot be scaled up further. All that jugaad kind of things cannot be scaled very well. And so you need to invest money. If we ever want to become knowledge economy, if we ever want to develop new products out of what we do in research institutions, we need to invest more and more into that process. And so India is currently spending less than even the BRICS nations, right? I mean, even the averaged out to the purchase parity, we are spending much less than any of the other countries right now, which is a matter of concern. So we need to be, able to do better than that. And then the second thing is we need to protect IP. We need to learn how to file quality patents. For example, in 2019, in nanotechnology area, which is my area of research, we wrote about 15,000 papers, and we are ranked third in the world in terms of research in nano, but we filed only 54 patents. And during the same year, US wrote about 24,000 papers, ranked second in the world, but filed close to 5,000 patents, right? The patents to publication rate in the US is about 4 to 5. Every 4 to 5 papers result in an IP, whereas in India, every 300 papers results in an IP, right? That is a very bad situation to be in. If you ever want to, develop the deep tech entrepreneurship ecosystem, you need to file patents. If you don't have IP, there is no company, right? Even if you start a company to do something, the first thing that the investors ask is, do you own the IP? And if you don't have that IP for the technology that you are going to use to develop a product, I think nobody will even touch your company with a barge pole, so which is a challenge here. So we need to protect our IP if we ever want to, use that knowledge for development of products. So this is where the problem is. India, the three aspects that I talked about: innovation, education, and research. Our research is entirely driven by what happens in the library. Right, most of the library papers is what we read. We pick up problems from there. We do some more work and publish that work back in library. Right, so the most of our research is now anchored around the libraries and what is happening in the libraries in terms of research publications and all that. But the research needs to link ideally to something like research needs to link to industry. industry should be collaborating closely, the societal problems, the line ministries, the strategic agencies, all of these need to play a role in defining the research problems in academia, in addition to just picking problems from literature review and all of that. So that is what that needs to happen. That is the direction that we need to move as we go ahead into the future. This was the article that I wrote in Times of India, which you were referring to. I said, why are we not developing, why are we not doing great science, right? We are not doing great science because, lot of our top talent is going for engineering, and even in engineering, it's primarily computer science kind of areas. So I think, our top talent not doing science is a big challenge for India. But if you look at a simple mobile phone here, right, any of these modern mobile phones, these are all technological marvels. If you ask me what is the most complicated device that we use in our daily lives, it's actually these mobile phones. A lot of technology goes into building these mobile phones. But behind these mobile phones, which is seen as a technology, which is seen as an application, there are at least a dozen Nobel Prizes, right? I mean, there are Nobel Prizes awarded to display, the camera, the wireless, wireless technology, battery, memory, processor, polymers, transistor, every aspect of the mobile phone, as resulted in a Nobel Prize. And by putting together those dozen or more Nobel Prizes, which is the great science that has happened out of all of that work, one is able to eventually build a mobile phone. So therefore, without great science, there cannot be any great technology. We need to invest in science, right? I mean, so I think that is something which is very critical for the country to do. We need to see how to make, science a kind of glamorous, right? And people, great mathematicians, great chemists, great physicists must be celebrated in the country. That is when we will actually give importance to the science, and then, that's how they do great science, and that is how you develop new technologies out of that science, and that is when all these great products, start to come out of India. And I think, our investments in science, are the first step if we ever want to, become a great technology nation. So I think this is something which is very critical. Another thing that is also a problem in India is lot of university research ends up with the TRL, the technology readiness level of 3 or 4, right? 3 or 4 is a proof of concept. From a laboratory prototype, proof of concept is 4 kind of a thing. So 3, 4 is where a lot of university research ends up, and commercialization happens at 9, 10 technology readiness levels, right? But who will actually develop this proof of concept and turn it into a product? That is where industry collaboration becomes important. That is where you need to have, dedicated institutions which actually can help academia to do that. And all countries which have done very well in technology space have actually done that, right? India doesn't have any institutions which can look at the university research at TRL 3, 4 and convert that into a product, the TRL 8, 9, so that industry gets interested and takes that product and manufactures it. I think this is the kind of a challenge that exists right now. Most of our technologies see this valley of death. That is where creating institutions which can actually bridge that gap of TRL 3, 4 to 8, 9, it becomes very, very important. I have some ideas. I have written policy papers on this. I have been taking it up with government to create such institutions. Without doing that bridge that connects academia with industry, that is currently broken, and that is also the reason why neither our industry is able to develop innovative products, nor is academic research getting translated into something which is useful. So I have ideas on that, creating labs and all that, but I won't get into that. Another problem that exists in India is the siloed higher education system, right? Innovation often requires a multidisciplinary approach. A product is always a multidisciplinary approach. With one single discipline, you cannot develop a product. And problems don't come with a disciplinary tag. So therefore, if you want to make your research, focused on solving a problem, then it has to be, a kind of a multidisciplinary team. And that is what we should be doing. Unfortunately, our institutions are highly discipline oriented. We don't have enough multidisciplinary universities in the country. I think that is one thing. Even at IIT Delhi, I tried to change it. We created at least 10 new departments and centers during my time as the director of IIT Delhi, where we wanted to make IIT Delhi, develop this culture of a product innovation. The same is something I am doing in BITS Pilani too. And there is a lot of bureaucracy. Another major problem in India is the unease of doing research. The ease of doing research has gotten so bad right now. And that is also the reason so many research scholars not receiving stipends on time, right? People not receiving stipends for a year is actually criminal, right? I mean, a country, how can we have a PhD research scholar not receiving the monthly stipend? I mean, I think that's all because of the bureaucratic hurdles that we have created for ourselves, and I think we need to unshackle them. Unless we remove all these hurdles, I call them the 5 Gs: the GFR, GST, GEM portal. Now, this is the global tender inquiries for purchase of equipment, which is all needs to be approved by Secretary, Ministry of Education, and governance again is a major problem for science and technology. So I think these 5 Gs are what I believe are essentially killing whatever research and innovation potential we have. That's another problem. At the institution level, a lot of things need to happen. At the national level, I told you all of these things need to happen at the national level. At the institution level, for example, we need to connect institutions with outside world. In IIT Delhi, for example, that's exactly what we did. In IIT Delhi, I called it idea factory approach. What is an idea factory approach? Idea factory approach is bring unlike minds together, right? And people from different cultural backgrounds, people from different disciplinary backgrounds working together. When I was the director at IIT Delhi, we not only started multiple, academic units with that multidisciplinary focus, we also connected IIT Delhi with all these great institutions around around house cast, right? AIMS, All India Institute of Ayurveda, Indian Council for Agricultural Research, NIA, ILBS, RCB. All of these essentially meant that we funded faculty to go and collaborate with people outside. That resulted in a lot of interesting research. And then when I say unlike minds, different cultural backgrounds, different disciplinary training, and different attitudes, again bringing academia and industry closer, right? So we did lots of initiatives at IIT Delhi. We took lots of initiatives to basically bring industry and academia together. In fact, IIT Delhi was one of the first institutions to start this process of practice positions. Industry Day we started. We created a dean for corporate relations, and then staffed it with people who are from industry. So a lot of things we did. And then once you build that ecosystem for that kind of research, the multidisciplinary research, now you go ahead and see how some of that research can become startup, right? So there again, we actually started a FIRE program. If faculty members say that I want to start a company, institute funded them up to 50 lakh rupees as a grant. Institute gave them sabbatical so that these faculty can go and start companies and employ their PhD students. Whenever a faculty member is doing something, PhD students are always part of those initiatives. In fact, during my time, we started a PhD incubator, the platform for harnessing deep technologies. We said the postdocs, right? If they want, a PhD student wants to start a company out of his or her research, institute would give them stipends up to 75,000 rupees, give them grants, and then using all the grants and stipends, can you convert your PhD problem into a prototype? Some of these, we did, and student startup action plan. So a lot of such things we created at IIT Delhi during my time director for 6 years, and we could immediately see the results. In IIT Delhi, within that 5 years, we actually filed more patents in that 5 years than the previous 55 years, right? And multiple new academic units. We had 350 plus industry projects, during those 5 years, and more publications, 3x in number of funded research projects, 4x in terms of research funding. All of these things became possible because we just brought the institute out and from its silo and connected it with all the institutions around that. And in fact, when I left, this was the situation where we were connected with 275 plus companies versus 50 companies 5 years ago. So that was a kind of an impact we could make. And even during the COVID time, right, we could develop so many projects and so many products. At least 10 million people benefited from the research that came out of IIT Delhi in terms of products and prototypes. So I think that potential exists in the country, in our higher educational institutions, when it comes to translational research. What is needed is to bring these institutions out of their silos and then connect them with real world problems and connect them with stakeholders outside. I have probably another 10-15 minutes I need to close, but I will also bits Pilani, for example, I said we need to reform our PhD programs. Our PhD programs are stuck in time, right? I mean, our PhD programs are also essentially are training grounds for producing university professors, right? Other than faculty kind of a job, we are not giving enough training to our PhD students, to a large section of PhD students. We are training them to become faculty. But then that's not the only requirement of a PhD program. For example, at IIT in BITS Pilani, I started a PhD program called PhD Drive. You can search it on the web. Drive stands for Deep Tech Research, Innovation, Value Generation, and Entrepreneurship. I want to see PhD students after 4 years become entrepreneurs, right? From day one, they are given a project at a higher TRL level where a proof of concept is shown, and their output of the PhD work is a prototype. They will write a few papers, file patents and all of that, but they will be focused from beginning to start a company out of what they are doing. We are paying them 50% higher stipend as compared to the regular stipend. We are giving them 10 lakh rupees, to build a prototype. And this program has attracted so many top students. Now we received 1,300 applications for the PhD Drive program, the first round when we opened it. We have also started another PhD program called PhD Impact. It is industry-mentored PhD in advanced and cutting-edge technologies, where again a PhD student has to be associated with an industry. The industry is either funding it or providing the problem statement, doing internship there, and such a close linkage with industry. Once they graduate, the industry would actually want to hire them. I think some of these innovations are required in the PhD programs, and which is what is required now if you want to find more PhDs getting gainfully employed in industries, or if you want to turn them into entrepreneurs. So having said all of this, at the institutional level, at the national level, I will talk in the next 10 minutes that I have. I will talk about at the individual level, right? Am I only preaching, or have I done something on my own in this kind of a respect? I always worked on on a very focused kind of a problem-oriented kind of research. That is what I have been doing. And my group has always been multidisciplinary kind of a group, right? I'll skip some of these. But for example, one of the very early problems I started working on at IIT Bombay, where I spent 18 years as a faculty member, is a multidisciplinary team consisting of 5 different departments, where we wanted to develop a low-cost cardiac diagnostic system, essentially detecting cardiac markers, right? And to detect those cardiac markers, along with a team of faculty from multiple departments, our goal was to develop a prototype which can detect at least 2 of the 3 markers, troponin I, CKMB, or myoglobin. So that these are all the cardiac markers. If you can monitor them in a very low-cost fashion, you can actually diagnose the heart conditions pretty early on. That was the whole idea. To develop this, in my group, we started with a block diagram, like any would do when they want to develop a product. So we were very clear from the beginning what you need to do. You take the blood sample, you filter it out, you have microfluidic channels, you have the sensors, for all of these biosensors, and this entire thing is disposable. And then a small tabletop unit, which will actually, where this cartridge will go and where the display for those cardiac markers will be shown. And once we did that, Then different departments started working on, one was working on blood plasma separation, one was working on microfluidic channels, some departments working on biosensor array, some were working on integration, some were working on electronics. I think, we had that kind of a project at IIT Bombay. That was the first project at IIT Bombay, which was multidisciplinary in nature. And then, so in my group, I started working on these, cantilever systems. All of this research is published. You can find it on my webpage. So idea is to develop these nanomechanical sensors where you quote a receptor here. The receptor will bind to the corresponding protein, and when the binding happens, then you detect it electrically. These are all piezoresistive sensors. Any selective reaction here is what you detect electrically. So we started developing this entire platform using a lot of nano principles, and we published many papers out of it, filed many patents. Since I don't have much time, I'll skip some of these technical details. But we were able to actually develop the entire system, and we were able to actually demonstrate a complete prototype, and it was funded by a ministry. And ISENS here stands for INFOX sensor, standing for myocardial infarction. And so we then incubated a company, NanoSniff, and then transferred this technology to NanoSniff, so that this cartridge, for example, can detect multiple proteins in the blood. That was the technology demonstration, a proof of concept, and then NanoSniff was supposed to take it forward and do all of that. And once we developed that platform, then we also started using the same platform for explosive detection, where again, you have these explosives. You take the same cantilevers, now you coat it with receptors which can bind to vapors of explosive, something like this. So you coat these receptors which bind to vapors of explosive. When the binding happens, then the stress strain happens, and then the cantilever deflects, and you sense because these are all piezoresistive cantilevers, you detect it electrically, kind of a thing. So the coatings in this case are these chemical receptors which can bind to vapors of explosives. So I interacted with a lot of chemists. We wrote lots of good papers out of that. We did all of that. And then we developed an electronic nose platform using a similar principle with multiple cantilevers and all that. We called it XSniff. And so this was a prototype of XSniff, which we developed at IIT Bombay, demonstrated. We again wrote lots of papers, filed many patents. And some of this work eventually led to development of an explosive detector, right? Which is now in the airports. You will find it at least in dozen airports in India. And so our idea was very simple. Our idea was, how do you detect explosives? We tried a lot of chemistry-based approaches, but the selectivity was still a challenge there. Then we turned into physics, right? We turned to physics. What exactly here is the idea? That you take a few nanograms of explosive, you cause a nano explosion. When they explode, because these are all exothermic reactions, they release heat. Now you look for the heat signature, the temperature signature, thermal signature. The thermal signature of the nano explosion is what we use to actually detect the explosives. So that was the idea, very simple, neat idea. And then we filed for patents, Indian, Europe, and US patents. All the patents got granted. And then we developed this now into a prototype. I have a small 2-minute video, which is what I will play, which will give you an idea about this technology.
Advanced Technologies, an IIT Delhi incubated company, and NanoSniff, an IIT Bombay incubated company, manufacture and launch NanoSniffer, an advanced and affordable explosive trace detector, screening visitors and passengers for explosives at various public or crowded spots have become the norm due to the increase in the terrorist activities around the globe. Every luggage and person passing through the security checkpoint is tested by the security officer to check whether they have traces of explosives on their surface, skin, or hair. NanoSniffer proudly claims to be the first explosive trace detector in the world using microsensor technology. The microsensor of NanoSniffer is made using micro-electromechanical system, MEMS technology in semiconductor fab. The sensor uses fabrication techniques such as lithography, etching, deposition, spin coating, and finally released to the microsensor. The core technology is protected by patents in the US and Europe. All of our actions leave trace behind. which is then screened by the security personnel. The security has to concentrate at the sampling areas that are likely to be touched by hands. In the case of a bag, this will include handle, buckle, and zipper. Post-sampling, the swipe is inserted into the system where microheater subjects the particles into rapid heating. In case of explosives, this trigger exothermic reactions which are picked up by the integrated temperature sensor of the microheater, thereby landing each compound in its own thermal signature. The algorithms use these signatures to distinguish between explosives and non-explosives. Further analysis of the algorithms help in categorization into the appropriate class of explosives. The follow are few nanosniffer features. It is the first microsensor-based ETD. It detects and identifies explosives in less than 10 seconds. Identifies and categorizes explosives into different classes. Can detect ng quantities of explosives traces. It detects all classes of military, conventional, and homemade explosives. It is portable and affordable. It gives visible and audible alerts with sunlight-readable color display. Nanosniffer, explosives trace detection technology, can be deployed at airports, railway stations, ports, malls, metro stations, corporate parks, hotels, and tourist spots. The goal is to intercept and prevent access of explosives trafficking. Nanosniffer is 100% made in India product.
This is something that we have been able to commercialize, and this was launched by the Honorable Minister of Education at that time. It was during the COVID time, and so this is the product here, and now it has gone to multiple airports, and the company NanoSniff, right, which is now commercializing this, and I mean they developed it, of course, completely based on the initial ideas in our group, and my past PhD student is now the CEO, is running this company, and so I think things have happened very well. And so this, as I said, the nanosniffs are now at airports and all that. And then in my group, we moved on to developing, miniaturized explosive sensors using this principle for applications in, buses, trains, and all of that. And again, here, the idea is, can you power them from the vibrations? So we developed piezoelectrics. So many of my PhD students worked on piezoelectric technologies for this explosive detection. So and a lot of work happened. And once I moved to IIT Delhi, then between IIT Delhi and IIT Bombay, we started a project for agricultural applications. And so here again, we started with a problem statement. The problem statement is Government of India has given these soil health cards to farmers, and which contain a lot of macro nutrients. The question we asked ourselves is, can we, between IIT Delhi and IIT Bombay, can we develop a complete suite of technologies for detecting these macro nutrients in the soil and make it very affordable for farmers, so that we can reduce the input costs in farming, so the farmer income levels will go up. So that was what we did. And then our project from the beginning was developing prototypes. The papers are byproducts of the system. Developing prototypes and then taking it forward to a startup was what was our approach from the beginning. So we worked on it. And in fact, in 2019, we started our second company, SoilSense. And SoilSense recently released this product, NutriSense. It's a soil glucometer. It can do nitrate, phosphate, potassium, pH, electrical conductivity. So one system that does 5 different parameters in the soil. Now this is commercially available. It's a NutriSense, and now they are working in villages in multiple states. They are already exporting this product now. The product works very well. In fact, SoilSense, now if you search on LinkedIn and other places, you will find this company. And this is again run by my former PhD student. After graduation, she became CEO of this company, and she has built this company now. And so this is again, the SoilSense has a suite of technologies for agricultural applications, and they work with multiple big companies as the technology partners. And so now, after moving to BITS Pilani, I just started a project on dosimeters. And this is a project between IIT Delhi and BITS Pilani. And so between Delhi and BITS Pilani, I had developed this technology when I was in IIT Bombay, along with my PhD students, Harshil and others. So here we developed a gamma radiation dosimeter. We are actually using a sort of a organic transistor based patch, right? An array of organic transistors, and using them to detect gamma radiation. And now, so we have these tiny patches which are flexible, which can be put on the body, and they can measure radiation, particularly for cancer therapy, right? Where cancer patients go through radiation therapy, their measurement of radiation, the dose as well as profile, today requires pretty expensive technologies. They're all ion chambers is what they use. Our idea is to replace them with simple organic patches. And so we owned the US patent. And now I'm building a team here in BITS Pilani jointly with IIT Delhi to actually develop this into a commercial product. And I'll skip that, but this work has just started now. But that is the way. So most of my research starts with a problem statement, and then to a multidisciplinary approach, we develop the prototypes, and then using a startup, we commercialize it. Not everything becomes successful, but at least my two startups, NanoSniff is doing very well. It's not a startup anymore, fledged company. They operate out of Bombay. And then my second company, Soil Sense, they operate out of Pune, and both are run by my ex-PhD students. And they are doing very well in the market. And so these are the products they have. Therefore, India is opportunities, right? Strengthening these academia startup industry collaborations is the key. And I think we need to make our R&D institutions primarily, currently we are all driven by what happens in US and other European countries. I think we need to innovate in areas where there is a domestic demand, and we need to focus on systems approach. Developing the full system needs to become the focus for our research. And local R&D for product development is absolutely essential, because our explosive detector product is the world's unique product. It's also the most the cheapest in the world, right? And we can beat any other company right now for explosive detection. That's how they are able to make business right now. But that has happened because it was entirely developed in India, in IIT Bombay, essentially. And it's possible to do high quality research now in academic institutions and yet make it relevant to India's needs. I think that's what we should be doing. And I should tell you one thing this government has done very well is there are multiple funding schemes from various government departments for startups in this area. They're all looking for funding deep tech startups now. So if you have ideas, even BITS Pilani will be happy to fund you. If you have a good research idea which you want to turn it into a prototype and all of that. I think at the end of the day, creativity in our higher education sector is as important as literacy at the grassroots level. This is something we need to realize. Just my last slide. There is this very interesting smile curve, right? What is the smile curve? The value addition is what I am showing here versus production chain, right? Where does the value addition happen in a company? The companies which do the product design, right? The conceptualizing the product, they are the ones who generate the highest value. And then the sales, after sales, marketing, these guys make the highest value. Look at the case of Apple, right? Apple basically designs the products, right? And then they get the manufacturing done in Taiwan to Foxconn and all that. But Foxconn is, Foxconn's total valuation is about 60-70 billion US dollars. But Apple valuation is $3 trillion. That's the difference. The companies which actually design products, think of new product ideas, are the ones which end up getting the maximum returns in all of these kind of cases. And the manufacturers are always working with the lowest profit margins. I think we need more startups today out of our PhD students, out of our research, which can conceptualize these product ideas and realize them, right? The manufacturing can get it done anyway, right? That's what I hope to see more and more PhD students, more and more research scholars eventually do. I'll stop here. I have always had a large group at IIT Bombay. I mean, now I don't have too many students working, but I have started that organic project now here, and I hope to build a group soon. Thank you very much. I'll stop here. I will unshare it now.
Excellent talk, Professor Rao. I'm sure that many participants here now online and after this will be in offline, the YouTube will get benefited. And definitely this talk is going to change the ideas of many researchers all across India and Indian researcher who is working outside the India as well. So I have a lot of questions in my mind. So with the participant, if you have any questions, please write in the chat box and then I ask the questions to Professor Rao. But before you write, I have some questions, sir.
Please.
So my thinking is that still I go with your viral article that say that why India is not having a lot of Nobel laureates. So if I see the Nobel Prize is basically basic science-driven research. And whole philosophy of India's research at the moment, what I understand with my little knowledge, is translational, because lots of my friends, they are PI now in India. They think, oh, you can't do the brainstorming idea, risky idea there, because the funding agency want them to do something translational, like, drug-driven things, medicinal things. So wouldn't you think that this is too bipolar stuff? They are not going in the same directions. If you really want to try, you give a lot of money to do the basic science, then you ask the researcher to do a translational part of the science. So could you throw the light on that?
I totally agree with you. In fact, I'm not a great fan of, only applied research. There is nothing like applied and basic. If you ask me, all basic research of today will become applied tomorrow. The quantum was a basic research for 30 years. Now everything is quantum, right? So it has taken 30 years. Some take longer time, some take less time. Even look at Einstein's, for example, gravitational waves. Who would have thought that gravitational waves, is applied? It was always a basic research, blue sky research, monitoring gravitational waves from space. Nobody thought there can be any application, right? But once these gravitational waves were proven recently, now everybody is using gravitational waves as a probe to explore outer space. Earlier, telescopes were the only way you could see outer space. Now gravitational waves have soon become another way to probe the outer space. I think there is nothing, in my opinion, as basic and applied. All research, there is only good research, bad research, right? All basic research of today can become applied tomorrow. We must never cut down the funding for basic research. I think that is one mistake. India is overdoing this applied part of it. And like I told you at the beginning of this talk itself, I would like to see more and more funding for basic research and good research, good science, basically. And all technologies will come out of that.
Oh, thank you very much. I have a second question related to your nano sniffer. It's an excellent thing. Congratulations for that. With my little biological science students. So if it is a temperature-driven sensor, then how do you combat if somebody's trying to hide with the insulation kind of stuff?
No, we actually call the nano explosion. In this case, we collect a few nanoparticles either through a swipe or from the vapor, and then we explode them. We have a micro heater inside the nano sniffer. The micro heater basically rapidly heats them, basically causing a deflagration. When that happens, these explosives go through deflagration, they release energy. Because these are all exothermic reactions, these are all high energy materials. That energy release is what we monitor as a temperature change. So that's what we do.
Okay, thank you very much.
So all kinds of explosives, homemade, anything, wherever you have a thermal signature, you can measure the thermal signature and use it as a sensor. So it works across all kinds of explosives, unlike many other explosive detectors which tend to fail, for mixtures and for new kinds of explosive materials.
Thank you very much. So now I'm going to take the audience questions. The Ankita Thakur is asking that where to submit the research idea for the funding.
It depends on what the funding is, but BITS has created a fund now for supporting deep tech startups, right? So you should look at we have what is called known as PIDES, PIEDS. PIDES stands PIDES, PI stands for Pilani Innovation and Entrepreneurship kind of a thing. So just search for Pilani incubators, and you can write to one Mr. Sachin Arya, who heads our incubation activities, and then or just write to me. I will connect you with those right people. In fact, we also have a technology innovation hub from DST, which also funds startups. Any good startups or ideas you have, if you have done the proof of concept, we will be happy to support you. So just write to me. I will connect you with these people.
Yeah, I think the same similar question is the Javed Islam. You have already covered that one. So Krishnanjan Seal is asking, what's the scope of fundamental science in India? You already explained that. Should physics undergraduate engage in the research intensive right from the first or second years? This is a very good question that if the young people wanted to.
Yeah. In fact, we are doing a complete curriculum revision in BITS campuses. I want undergrads, to get involved in research. We are creating UROP, Undergraduate Research Opportunities Program, and Super UROP. Right? To the UROP and Super UROP, I want undergrads to be associated with a faculty member for a research project, starting from their second year onwards. So that's what we are looking at right now. So I think which is required in my opinion.
And his second question is that what is the scope of particle physics in India?
I mean, all technologies, like I said, whatever you consider as basic today, will become applied tomorrow. I think good research and bad research. That's how I distinguish research. I think if you do great particle physics, it will open up so many applications in the technology domain too. So I think work in areas where you're excited about, where you are passionate about. That's what is required. Research cannot be done with a 9 to 5 kind of a mindset. Unless you become passionate about what you are doing, you will never be able to do anything.
So Amresh Misra is asking that how can we persuade the government of India to spend more money in the research?
I am writing articles. I have written so many articles now. I keep talking about it in all fora, and I work with DST also closely. Things are improving. The National Research Foundation is a step in the right direction, and they could have allocated more funds to NRF. The original proposal was 50,000 crores, but now government is saying they will fund 13,000 crores over 5 years. The remaining 37,000 will come from industry. Now, why would industry fund NRF? We need to see. And now DST is working on creating schemes for industry to support NRF. So I think we'll see how it happens, but things are slowly moving in that direction. So the pressure is there on everyone to invest more in science.
So the question of Ashish, thank you, sir. Ashish Chaudhary is that where you can find the industrial-based research, either in his PhD stint, PhD time, or after the completion of PhD, he has to move to industry and then pick up the translational questions separately. I think if I remember correctly, you were saying in the talk that in your institution, you are asking the PI to design a project which will be fit, academy and industry as well. So after the academics tenure, the student will fit to lead the industrial project. Could you
we are actually starting a PhD program in BITS, which is completely industry facing. I mean, you cannot take a student in that program unless the student's topic is given by industry, unless the funding is coming from industry, unless somebody from industry becomes a co-supervisor. That is the kind of a model. It's known as PhD impact program. And we are now getting connected with multiple industries for that program. So that's one way, you can get that industry kind of a orientation. So I think that is, as a PhD student, you may not be able to do that. You have to join an institution where that industry collaboration is a strong component, or a faculty member who is working with industries closely. There are many faculty in our institutions who are very, closely working with industries. I think you need to look for that. And once you become a faculty member, of course, you have all the freedom to do all of that. And I'm hoping that many of you who eventually become faculty members will do all of that I told you right now. So I think, the current people, they have a certain mindset, came from certain backgrounds, but, you are the future of this country when as far as the research is concerned, I think some of you should keep in mind the kind of aspects I talked about. So I think, do good research, write good papers, but then eventually orient your research towards, using it for some application, right? I think that is what at least those of you who are joining, technology institutions should keep in mind. If all of us only write papers, then who will actually, use that knowledge to do anything else? So I think industry connect is very important. So.
No, thank you very much, sir. So Mansi is saying that she's in a state university and she's inspired fellow. So she's saying that she has a lack of exposure for any internship or any kind of translational aspect. So where should she move for that?
I mean, you can.
She has also industrial experience, she's saying. She's lacking opportunity.
And I'm sure there are many institutions which might be interested in taking you. I mean, you can write to me. You can also explore the opportunities.
Or the one very common question from Soumya is that she is not receiving a fellowship from the DST. So yeah, that's
sad about it, and please.
Yeah, Dr. Pawan, I would like to ask the question because I'm not my side, and many scholars have some common question, and even we have done the meeting with the DST concerned person and 2-3 times. The main common question, the funding is if scholars are not getting the regular fellowship like agreement, how can focus toward the research?
I totally agree with you. So I think you should, as the All India Research Scholars Association, you must raise your voice. You should.
Yes.
I will be happy to amplify your messages, if you tag me. But I think you all need to talk about it. I think this is going too far.
Yes.
So only 2 questions left. So one is from Mudassir, one is from Irsad. Yeah, and then we will wrap this one. And we really enjoyed this innovative and brainstorming sessions and beautifully articulated talk. So Mudassir is asking that can social science research could be turned out to the innovation research? And if it is, then
I see that.
How can it link with science and engineering?
In fact, a lot of good things can happen by the involvement of social sciences. In fact, at IIT Delhi, I started a program. We said we gave funding to the humanities faculty. We said, now you would sign up with engineering faculty. This money is available to you only if you work with engineering faculty, right? Because I look at the humanities, social sciences as our window to the society. These are the people who are connected with the society much more closely than engineers, right? Engineers are, just always sitting in the laboratory and doing something, whereas social scientists are working on the field. And I think social scientists can pose the right kind of problems, and they can lead some of these groups in addressing some of these problems. In fact, wherever I work, whether it is IIT Delhi or IIT Bombay or BITS Pilani, I have always collaborated with humanities people because I think they are our window, in engineering institution like IITs or BITS Pilani, they are the ones who are our connect with the society. And involving them in research, understanding the farmers issue, for example, they understand it much better than any engineer does. So I think I see a huge scope for humanities faculty to, in all of these kind of research that I talked about.
So one last question, I think, from Irsad, who is saying that how can we make Indian postdoc too lucrative so that many students will not go to pursue the postdoc outside India? And would it be good to do the postdoc in India?
I think India needs to spend more money right now. With the kind of funding available, none of us can support a postdoc, right? A postdoc would require 70,000, 80,000, 1 lakh rupees kind of salary. And no projects that we get today can support a postdoc, which is unfortunate. And I think once the investments in science go up, then the projects will have avenues for hiring a postdoc, and then we can start hiring postdocs. So in the absence of it, it's always going to be a challenge to accommodate a postdoc in any project funding right now, because the projects are all subcritical funding. There is never enough money to hire a postdoc, unfortunately. This is again linked to the investments that we are doing in science and technology. The initial things I talked about where the country needs to, do more. I think this is one of the things that we need to do more. Until that happens, this is a problem. But there are some national postdoctoral fellowship schemes of DST. I think you should also apply to them and see, if some of them can be useful for you.
All right. So
Yeah,
one last.
Hi, Dr. One more question and last question. And every time we have in my mind some question like what do you think about the brain drain? Because sometimes I am thinking it is good to exposure in out of a country to as a postdoc and research scientist. But if we are losing our brain and like the creamy brain, and people have lots of talent and researchers have lots of talent, they are moving abroad and they are still doing the hard work and day and night. But if in my mind, is it there the brain drain or what?
I think, if you will, as a researcher, you will always look for a kind of a position where you can where you can contribute to research and work at a level that you want to work, right? I mean, I always say that it's brain in the drain or brain drain. At the end of the day, I would prefer brain drain than brain in the drain, right? So I think, if in India there are now better opportunities. There are institutions which offer good opportunities, but then it has become very competitive, right? I mean, for every position we are receiving like 100 applications, right? Every time you have a faculty portal open, there are like 7,000 applications now. How do you even shortlist? How do you screen? No institution is able to manage that kind of a thing. The reason for that is there aren't enough opportunities, there aren't enough positions getting created in India. That again brings us back to what I talked about at the beginning. The number of researchers per million population, India is at the bottom right now, right? We are just have about 250, 300 researchers per million people. US has 4,500 people. So we need to invest more. We need to create positions. We need to expand our good institutions. As I told you, Jawaharlal Nehru Center for Advanced Scientific Research is the best place in the country to do research, and they have just 45 faculty. Why can't they have 200 faculty? Our good institutions are so tiny, not recruiting enough scientists now because they don't have positions. Somebody in Delhi doesn't approve them additional positions. I think that is a problem. Our good institutions have remained tiny. And even universities are not able to recruit people because the state governments are not providing them sanction for those positions. I think there are lots of challenges in this country, and we have all been writing, we have been talking about it, but I don't make these policies, right? I don't decide these things. So our role is to bring awareness at all levels, where we work, and that's what I am trying to do.
So before I ask one last question, there is one question I should take because I understand the pain of not receiving a salary. Soumya is saying she DST Inspired Fellowship. Can you help her to have a fellowship?
You should, I mean, you should write to the DS, write to Secretary DST. He's a good man. Professor Karandikar, I was his colleague in IIT Bombay for 18 years. I can tell you, DST Secretary is a gentleman. He's a very good person. He's trying to do things. Now, I think you should write to him, directly write to DST Secretary. Don't write to anybody else. And I can
also ask, yes, sorry, she's also asking you your email address. But I think Soumya, you can get him on the Twitter or multiple places.
My email is everywhere. You just search with my name, you get my email.
So before I stop taking other questions, my last question is, it's a question of a lot of researcher here that when I see the top institution in Europe or in the US, like some institutions, not all, when they are screening the students, they are not checking the age limits, they are not looking their backgrounds and etc. Even some institution where I was in the Francis Crick Institute, London, or you must be aware that MBOs, these institutions, they are hiring the PI for 6+6 kind of stuff. So 6 years they give them. If you perform next 6 year tenure. In that way, you can, even if you have a less position, you can accommodate the multiple brain at the certain stint of the research, like 6 years you perform, and then if you are doing extraordinary, you will have a next 6 years, and then that's it. In that case, you give, if you have a less infrastructure, less money, you allow them to give opportunity of multiple brain to do the research. Can we in India, not at all institute, but top institute, start doing that, so that, because I know that there are lots of students who want to go back India, do something there, do the research in homeland, but because of the age limits or because of multiple bias, I would say they are not getting opportunity. Since you are at the leadership stage, so can we see in the coming future this kind of system in India as well, like we are seeing in CRIC, we are seeing in EMBO, multiple places?
No, at the entry level, you want people in a certain age bracket, which is understood, but at least I never believed in applying it very strictly. If 35 years is the upper age limit for a faculty member at an assistant professor level, if the faculty member, because the candidate becomes 35 years, 1 month, you don't reject the application, right? There are ways to, shortlist such candidates. The idea of that is, you don't want in a department an assistant professor who is, people joining at 32 years and people who are 40 years. I think you don't want, at the entry level, such a huge variation in the age groups and all that. But it doesn't mean that you have to, go strictly by 1 day more and you reject the application. That is a very bureaucratic thing, unfortunately. At IIT Delhi and even in BITS Pilani, we don't have any such problem. In IIT Delhi, departments, if they want to hire a faculty, even if the faculty members are 3 years older, 4 years older, director can approve that. Director can waive that requirement. It's only a recommendation. It's not a mandatory thing. But then, unfortunately, in many universities, 1 day more, they reject your application. I think, these things have become, unfortunately, very bureaucratic. But, sometimes some people, often say that it is because of the number of applications we are receiving, right? I mean, if for one position, if you receive 1,000 applications, now you leave it to the, the lower level people to do the screening. The person makes a kind of a chart, right? And 1 day more, then the person says not qualified, right? So I think that is also another problem. And again, it comes back to increasing the research base. We need to create more positions. And more way, our industry needs to recruit more PhDs. Even our academic institutions need to recruit more PhDs. Our gross enrollment ratio is pretty low in Indian higher educational institutions. We want to double it. How will you double it without increasing the faculty strength, right? All our IITs, all our universities need to double in terms of their faculty strength. But then, without the government funds, without the sanctions and approvals, I think the number of positions are limited. The number of applications are huge. And then people tend to apply all these cutoffs and all of that, unfortunately, very blindly. So I think, a lot needs to change. But at least wherever I am involved, you don't see that. I always encourage good people, irrespective of whatever age it is. Even in BITS, we don't impose any such criteria. So.
All right. So if there's no more questions, then I would give the session to the Lal. He will give the final word. He's our president for All India Research Scholar Association. Dr. Lal.
Yeah, thank you so much, Dr. Pawan. And I'm really thankful to Professor V. Ramgopal Rao and sir. You have given your precious time for us. And really, it was the eye-opening session. And I hope the people have enjoyed in such a session. And really, I got so many information, because most of the time we raise the issue. And even we have discussed with the DST and some higher authority. We want to support also at the ground level what scholars are facing the problem and challenges in their research life. We are not thinking, oh, we are just raise the voice. We are also supporter, but we want to make the good infrastructure in our nation for the welfare of research. And definitely, if we will get some good success at ground level, then our scholar will do the innovative research. They have the scholar have the brilliant mind, and they can do the innovative research for the nation development. So thank you so much, sir. And I am really thankful again and again. I don't have word to speak about you. Really, you have presented very well, and it was it was a good experience for me also in such a talk session. Thank you so much, sir.
Thank you so much. Yeah.
Yeah,
Good
thank you
night.
so much.
Thank you. Bye-bye.
Thank you. Have a nice weekend, guys.
Yeah.
Bye.
And thank you so much, all of you who join in such kind of session. I really thankful to all of you. And Mahinder, I sorry for
No, his question was answered already before.
Okay, that's fine. That's fine.
You
Okay,
have approached in this.
thank you so much, everyone, and hope you enjoy in wonderful session. Thank you so much. Thank you, Dr. Pawan.
All right.
Okay.
Good weekend, guys. Bye.